Hey guys, my name is Jake, and welcome to Tuesday, July 22nd, 7 out of 10 puzzle. So let's get right into it here. I'm not going to explain everything as thoroughly because if you're looking at the 7 out of 10, you probably have a good idea of how to play these killer Sudokus. So, first thing here, that's a 13, pretty unhelpful, but we know these are going to be the same digit. Let's take a look around here. Where do we want to start? Where to start? Okay, so that has to have a 1 in it. Let's see, where does the 1 go here? That's unhelpful. Okay, this has to add to... That has to add to 12 there. Which means there's always some symmetry in these puzzles. And this has to add to 11. That can't have a 1 anyway. That's not helpful. Oh, what am I doing? Here it is. So that is going to be over 90 by about 7. And we said this has to add to 11, so that's a 4, that's a 9, that's a 4, and that's a 5 there. And that 1 4 is removed, so you get 2 3, 2 3 4, leaves you with your 1 8 here. And so now this has to have a 7, also cannot have a 1, so that's 2 3 4. There, okay, we did know this added to 12 here, so that's a 7 there. That's going to have a 7, cannot have a 4 in it, nor can it have a 3 in it. So then that's going to be 1 8 9 there. Oh, here we go. Okay, so this is going to be some sort of roping pattern here. That's going to be a 2 3 4, and what are we left with? 5 6 7. It looks like. So we get 5 6 7 here. That's going to be a 5 6 7 there, and then we get another 1 8 9 there. Remove all the Sudoku bits. That can't be 7 there. That can't be 7. Okay, so now that 4 is removed. So that's a 1 2 5 here. And now this box here, that's a 30 plus 7, is going to leave us with another 8 and 3, which can only have... I guess it doesn't explicitly have to be 1 2 5. That could still be 1 and then 3 4 here. I don't really want to mark that down, but it does. It's going to have a 1 no matter what, so that can't be a 1 there. Well, obviously it can't be a 1, 8 or 9 there. And where does our 7 and 5 go? Here. 7 goes here somewhere. This is 26, so we're at 33, which is going to be 12 and 3. That is very unhelpful. This isn't going to have a 7 in it. And then it's going to have a 5 or a 6 here. Those all have 5s or 6s. Is there anything removed from here? Yep, that doesn't have a 1 there. 2, 3, 4, 5, 6, 7, yeah. Okay, that's going to remove most of that there. Now let's take a look here. That doesn't have a 4 in it. And yeah, those don't have 7s. Again, unhelpful. That's 5, 9, 6, 8. This is going to have a 1 because we know that can't have a 1 there. It's going to have an 8 or a 9 and then a 5 or a 6. That doesn't have an 8 or a 9. That doesn't have a 5 or a 6. That doesn't have a 5 or a 6. So we have our 1 here. 8s or 9s, 5s or 6s. So that's going to leave 3 or 4 there. And we can eliminate 3, 4. This can't be 3, 4 in it. Okay, where else can we look here? Feeling that. Okay, maybe over here. So one thing that you might not know about these Sudokus is you guys know the 45 rule, but whenever you have one box in and one box out, I always like to do this. So we already know this adds up to 90. So if this is an 8, we're going to be 8 over. So these are going to have to be the same digit. So this means that can't be 5 or 7, which is pretty unhelpful. I don't really want to mark that yet. But maybe here we have 4, 7, 1, 2, 5. So this is already 2 over. So if this is a 1, this is going to be a 3. And 2, 4, so on. So we get 1, 3, 2, 4, 5 is gone. And then, so we get 4 and 6, 5 and 7 is gone. 5 and 7 is gone. 6 and 8 6 and 8, or we have a 7 and a 9 there. That leaves a lot. But, okay, what 7, 9, not going to remove much. 6 and 8, which would leave us with an 8, and then you'd be, get rid of that one, so it'd have to be a 3 and a 5. 3, 5, 8. But that has to be 1, 2, 5 or 1, 3, 4, so that doesn't work. So our 6 and our 8 combination doesn't work there. Because if this were to be a 6 and this were to be an 8, you'd get a 3 and a 5, and it would break this 8 cage. Because then you'd eliminate 1, 3, 4, and you'd eliminate 1, 2, 5 there. So that cannot be 8. 3, 5, 8 is gone. Is 8 gone from this completely, is the question. 8, 2, and 6. 2, 8, 6, 1, 3, 4 still leaves a 5, 9 there. Would leave a 6, 4, 2, 8, 6. And then that would leave a 4 there. So we'd be left with 1, 3, 4, which would leave a 2, 3, 4. That seems kind of useless to compute. What is left here? We're left with 3, 6, 8, and 9. Could this be a 3 here? Because then you'd be left with 2, 4, 2, 3, 4. Not possible. So we're left with 6, 5, 6. Is 5, 6 possible? No, we'd need a 2 and an 8. So 3 and 6. So this has to be an 8 or a 9 there. Which, okay. So, yeah, we already knew that actually. Your 5 or your 6, 2, 3, 2, 4. Could that be a, no, 8. I don't think this is possible. Because we need at least 2 of our 2, 3, 4. So now we know this has to have a 4 in it, which cannot go here, cannot go here. So if this were to be a 4, we'd be left with 2, 3, which is not possible. So it does have a 4 in it. And yeah, 5, 6, 8, or 9. Where does your other 8 or 9 go? Let's take a look. The 7s and 5s are removed from here. 3 7s removed from here. What is that? That's 33. That's a 12 and 3. Again, we don't want to mark down too many digits here. This can't have a 4 in it. It needs a 2 or a 3, so all of those are removed. Then it needs a 5, 6, or a 7, which, so it needs 6, 7, 8, or a 9 there. 7's removed, so that has to be 6, 8, or 9. So that could be 6, 7, and then your 3 there. Could this be 6, 7? Because then 6, 7, which would leave you with a 14 or a 15, which would be, we're 10 under, so we'd be left with a 4 or a 5. So it'd have to be 6, 7, 5 here. It would be 6, 9, 6, 9, 7, 5, 6, 9, 6. You'd be left with a 2, 4. Yeah, 6, 7. 6, 7, 5 here. Yeah, 6, 7, 5. So you'd be left with a 5 here. That would eliminate 6s and 9s, so you'd be left with a 1, 8 or a 2, 7. 2 7's gone, so it'd have to be 8 and 1 here. 8 and a 1, which would leave a 3 here. Yeah, that's fine. I don't know why I wasted so much time on that. 4s have to go somewhere here. This can't be a 5. We know we have to have a 9 here somewhere. And what else? What is this? So that either has to add to 5, 5, 6, or 7. Could this be, could we eliminate 3 and 4? Yeah, you'd get a 1, 2, 9 here. Oh, no, what am I doing? This has to add to 10 11 or 12. 3, 4 is eliminated. You're left with a 3, 6, or a 9 there. 5. Let's see here. Those are linked somehow. No, not that. Four and 5. I must be missing something very obvious here. We know the relationship of this digit here. So we're 2 under, so that can't be a 1 or a 2. If it's a 3, it's a 1. That doesn't work, so it would have to be 4, 5, or 6 here. And the symmetry, where's our symmetry? Same thing here. I mean, we took a look at this. These are the same digit. We get a 4, 5, or 6, which isn't too helpful. This would be a 2. You'd be left with, if this was a 2, you'd be left with 1, 3, 4. And then that would eliminate those. So that doesn't work. 5, 3, 9, 6, 3, 8, 4, 5, 8. Does this have to have a 9 in it? Yeah, 9 can't go here. 4, 5, 8 would leave you with 6, 7, 9. Okay. So what am I missing here? What am I missing? I have it there. Maybe I'm missing something here. So we know this is to add to 10, 11, or 12. Could it add to 10? It would have to be 4, 6 to get your 5. 7, 9 is possible. What about 11? It would have to be 3, 8, and 6, which is definitely possible. And then to add to 12 here, you'd get a 3, 9, or 4, 8. So 7 would be removed from here, so you'd have to have 5, and then 8 or 9 here. Maybe I'm missing something else. This has to have a 1 or a 2 in it. This doesn't have a 1 or a 2. This doesn't have a 1 or a 2, so your other 1 or 2 goes over here. So this needs to have a 1 or a 2 in it. There we are. It needs a 5, 6, or a 7, which leaves us with 1, 8, and 9. Where does your other 8 and 9 go? 1, 2. This has to be 3 or 4 there. This can't have a 3 or a 4. This can't have a 3 or a 4. This can't have a 3 or a 4. Well, yeah, we know that needs a 3 or a 4 there. Could that have a 3 in it? You'd be left with 3, 8, and 6. So 3, 8, which would give you 6, and then you'd be left with 7 and 9. 7, so you'd be left with 7, 3, 8, your 6 here. 7, 4 would add to 11, so you'd be left with 6. Oh, there it is. Okay, so if this were to be 3, 8, then the only thing left would be 6, 7, or 9 here. 3, 8, 6, which would leave a 4. 3, 8, 6. Leave a 7, and 6s are removed from here. So this would have to be a 9. This would have to be an 8. Yeah. Yeah, 3, 6, 8. 3, 8, which would leave you with a 6, your 7, or your 9. And then your 7's removed here. and your 6 is removed here. So this would have to be a 9 and an 8, which would leave a 5 here, but that doesn't work. That does not work. Because, yeah, 8s are removed from here. So this can't be a 3, which means this must be a 3 there. And then your 4 has to go there. So this needs a 3 here, which is very helpful because that cannot have, this has to be a 6, and then 1, 9, which does leave an 8 here, removes the 6. Oops. I don't know what I did there. Okay, yeah, that's 9 gone, that's 6 gone. So 8 with a 5 or 7, but that has to be 5. That means that has to be 9, that has to be 7 there. And your 7 has to go here now. So 7's there, which leaves you with a 4, 6, 7, 7, 4, and 6. 4 and 6 there. Okay, so now your 6 is removed, which leaves you with a 2, 5, and you're left with 1, 2, 3, 1, 2. Let me go plug that in really quickly. 1, 2, 3, 4, 5, 1, and 8. That took me a while. 1, 8's removed here. Okay. So 4, 6. We know the relation. This has to be a 1 or an 8 now, because those are the same digit. Removes 1 and 8. That leaves a 2, 4, 6 there. 2, 4, 6. 4 is removed. And now what? This has to have a 1 or an 8 in it. 7's are removed. Can't have both 1 and 8 in it. 2, 6, 6, 9, or 3, 5. Okay. What else? This had to add to 12 there, so let's take a look. Need a 2, 4, or 6. Incredibly unhelpful. 7's are removed. Yeah, this is not going to be very helpful there. What about here? Could 4 go here? You'd be left with 1, 2, 5, and you'd be left with a 3 there. 4 would have to go here, here. Well, 2's removed from there, 3's removed from here, so 4's removed from there, which leaves you with 2, 5, and that leaves you with an 8 or a 9 here, which is pretty helpful because it can't have both an 8 and a 9. So 9 is removed from there, which removes the 7. So it's an 8 or a 9, then you're left with a 3 or a 6, and you're left with a 1, 2, 4, and 5, but 1's are gone, so that's a 2, 4, 5. Now 4 leaves you with a 6. 4 leaves you with a 6, and that the only way 6 can go in here is 8, which is fine. 8 or 9, then that leaves you with a 5 or a 6 there. And where does your 3 go? Nope. Okay, so is there any problem here? It's 1, 2, 5 or 1, 3, 4. 3, 5 is gone. Okay, we already knew that. 5, 9, or 6, 8. So, well, 1 is gone, obviously. So that's an 8 or a 9, 3 or a 6, which leaves you with a 2 or a 4 there. And now what else here? What am I missing? 3, 4, or 2, 6. 2, 6 would leave you with 5, 9. Yeah, you'd be left with a 2, 5 there. 3, 6, 8, 9. 6, 3, 1. This has to have a 1 or a 4 in it. So let's eliminate all of those, and then it has to have a 5, 6, or a 7 there. 5, 6, or a 7. And what's eliminated? 1, 4, 5, 6, 7. Is 3 eliminated? Not yet. it would seem that 9s can only go here, as well as 8s. So we can remove the 8s and the 9s here. And what else are we left with? 1 or 4. That's 8, 9, and then 8, 9, 3, or 6. This could be 3, 4, 7. 3, 4, 6, 7, 3, 3, 4, 7. Would leave you with a 2 and a 6. Your 8 would go here. And 3, 4 would eliminate that. Where does your 1 go? Where does your 1 go? That needs an 8 or a 9. So what else am I missing? Probably some very easy Sudoku. Where does your 7 go? Well, 7 can't go here. 7 can't go here, nor can it go here. So 7 is left in there. 1, 6, 2, 5, or 3, 4. That's 1, 6, 2, 5, or 3, 4. So where does your last one go? 1, 6. Could 1 and 6 go here? Definitely not. So yeah, the question is, could this be a 6 now? Because that would eliminate the 6s, so you'd be left with 2, 5, 3, 4 here. And then your 1 would have to go in here somewhere. So you'd be left with a 5 here, and then you'd be left with an 8. Yeah, 6, 8, 9. That's actually fine. Huh. Okay. So what else am I missing? What else am I missing here? 2, 3, 4, 5, 6. Two, 5 is going to have to go somewhere here. This is a 1 or an 8. What about here? Or here? Six, 9, 7, which is fine. 7 would go here. 4 and 6. Oh well, okay. If this were to be 4, 6, 7, where would it go? 4 would go here. Then your 6 and your 7 would go here, and then where would your 6 and your 7 go? So this can't be 4, 6, 7. And now you have a 9. You also have an 8. And you're left with 2, 7 or 3, 6. So if this were to be a 4 now, you'd be left with 2 and 6, and that would eliminate both of these combinations. So that has to be a 4 now. And you're left with 2, 6, 2 or 6. So you need a 3, 7 somewhere here. You need a 3, 7, and what's left? We're left with a 1. So 1 has to go here. You need a 3 or a 7 in there. You need a 3 or a 7. And now you're left with 2, 4 or 2, 6. 2, 4 or 2, 6. But no matter, or 2, 4 or 4, 6. So no matter what, this has a 4 here, which eliminates the 2, which leaves a 3 there, which leaves you with 6, 7. So 6 and 7, or 5 and 8. That can no longer be a 9. And that cannot be a 6. That's 5 and 7 there. 8, where does your 9 go here? 9 can't go here, nor can it go anywhere here. That must be a 9. And now Now what else? Oh wait, 2, 4, 6. What am I doing? That's an 8 there. 3, 8 leaves you with a 5. Now 5s are removed here, 6s are removed here. That leaves you with a 7, and you get a 1 or 4. That does leave you with a 3 or a 6 there. 2, 4, 6 is removed from here, so 2, 4, 6, which does leave you with a 1, 9. Does leave you with an 8, 1, and 8 there. And that leaves you with a 3, 5. 3, 5. 3s are removed here, so that's a 1, 7, which means that's a 3, 6 now. That removes 6 and 2 and 6 there. 3s are removed here, 5 is removed here because of that, 2 is removed here. And now 2 and 4 are gone there. 4 is gone from here. 7 is gone from here. 6s are gone from here. 4 is gone from there. Which leaves you with 6, 7. And where does your 5 is eliminated here, which also eliminates the 2. That also eliminates 1, so that is a 3 and a 4, which now eliminates 2, 3. 3, 4, which adds to 7, which now this means this has to add to 10. 1, 9 is fine. 2, 8 is gone. 3, 7 seems to be okay. And 4, 6 is gone. Oh, well, no, 3, 7 is not possible because that's already 3 and 4. So that's a 1, 9, which leaves you with 1, 2, 3, 4, 5, 3, 6, and 7 and 8. Anything else we can remove here? Seems to all be Sudoku from here. That's a 1, so that's a 4, which does leave a 3, and a 6, which goes with your 2 and your 8. That removes 8 and 6 as well. That's 5, 9. 4 is removed. 3 is removed. 3 is removed from here. Oh, wait, I messed something up very heavily. That's not 3, 6, 7, 9. That's 3, 6, 7, 8. Does that actually impact anything? We didn't remove any digits because of this 9. So I'm going to say that is okay logic. 1 9s, 1's 8s. So we have an X-wing here of 1s, which means that can't be a 1. That's a 7. 7 is removed from here. 7 is removed from here. And now 6 is removed from here. 4 is removed from here. So we're left with a 2, 5, which go here. We're left with a 1 here. A 1, 2, 3, 4, 5, 6, and a 7. 7 goes there. 6 goes somewhere here, which has to go here. That has to be a 1. That has to be a 7 there. 7 is removed from here, as well as 8. 6s are removed from here now. 6s are removed from there. That's 3, 7, and 8. And now simply just finishing out the puzzle. 3, 5. You're left with a 3 and a 2, which eliminates the 4 and the 3. And now 9s are removed from here. 1s are removed from here. 8s are removed from here. 9s are removed from here. 1s are removed from here. 2, 3 is gone as well. Our 6 is gone. Our 3 is gone. 3 is gone from here. So 5, 6, 7, 8. 6 is gone from here. Let me make sure I didn't mess anything up there. 8's gone from there. 7's gone from there. Our 5 and our 6 is gone. 7 is gone from there. 8s are gone from here. That has to be a 9. 9s are removed here. Make sure my computer's not dying. 9 is gone. 1 is gone. 1 is gone. 8 is gone. 6 is gone. 3 is gone. 2 is gone. 5 is gone. Let's see if we can finish this under 30 minutes. 3 and 8 are gone. And that's the puzzle. Thank you guys.